Welcome to a Sim Code. Want to learn more? Like and subscribe to stay in the loop for all things coding and development. The Caesar cipher is a type of substitution cipher, which is one of the oldest and simplest encryption methods. It's named after Julius Caesar, who is believed to have used this cipher to protect his private messages. In a Caesar cipher, each letter in the message, also called the plaintext, is shifted by a certain number of positions in the alphabet. This means that if you want to encrypt a message, you replace each letter with another letter that is a fixed number of steps away from it in the alphabet. This example demonstrates how to implement a Caesar cipher, a simple encryption and decryption technique. The code provides two main functions, one for encrypting a message by shifting each letter in the plaintext by a specified number of positions, and another for decrypting the message by shifting the letters back using the same shift value. The example encrypts the message, "Hello world," with a shift of 3, producing the encrypted message, "Korzrag," and then decrypts it back to the original message. In summary, this example shows how to use the Caesar cipher to encode and decode messages by shifting the alphabet's letters forward or backward by a fixed number. This is the function that performs encryption using Caesar cipher. Create an empty string to store the final encrypted message. Encrypted_message will hold the transformed message. Loop through each character in the plaintext message. Check if the current character is an alphabet letter, uppercase A to Z, or lowercase a to Z. If the character is a letter, check if it's uppercase or lowercase. If uppercase, set the base to 65, ASCII value of A. If lowercase, set the base to 97, ASCII value of A. Shift the character by shift positions and wrap around the alphabet if necessary. Word char converts the character to its ASCII value. Subtracting base normalizes the character to a 0 to 25 range. Adding shift applies the cipher's shift, and %26 ensures the result stays in range. Adding base converts it back to the correct ASCII value for the letter. Append the shifted character to the encrypted message string. If the character is not a letter, like spaces or punctuation, leave it unchanged. Return the final encrypted message. This is the function that decrypts a Caesar cipher message. Create an empty string to store the final decrypted message. Decrypted underscore message will hold the original message after decryption. Loop through each character in the encrypted message. Check if the character is in alphabet letter range, uppercase A to Z, or lowercase a to Z. Check whether the character is uppercase or lowercase and set the base accordingly. Shift the character back by shift positions and wrap around if necessary. Subtract shift instead of adding it to reverse the encryption. The %26 ensures that the shifted character wraps around within the alphabet. Append the shifted character to the decrypted message string. If the character is not a letter, simply add it without changing. Return the final decrypted message. Example of how to use the Caesar cipher functions. This is the original message to encrypt. The number of positions we want to shift each letter, the cipher's key. Encrypt the message by calling the Caesar cipher encrypt function. Arguments, plaintext, the message to encrypt, shift, how much to shift the letters. Print the encrypted version of the message. Decrypt the message by calling the Caesar_Cipher_decrypt function. Arguments: encrypted_message, the message to decrypt, shift, the same key used for encryption. Print: the decrypted message should match original. Now run our code. Okay, let's make a deal. If you like this video and subscribe, I promise I'll keep bringing you more awesome coding content. No bugs, no errors. Well, okay, maybe a few bugs, but I'll help you debug them. Seriously though, hitting that like and subscribe helps me out a lot and ensures you don't miss out on any future videos. Deal?